Lesson 3, Analysis Methods. Section 3.5, Thevenin's Theorem. Assume that we have an unknown circuit that has M resistors and N DC voltage sources. The interconnections inside the circuit are in a black box. If a resistor RL, called a load resistor, is connected to the terminals A and B, what will terminal voltage VAB and the output current IL be? To answer this question, measure the following two electrical quantities. One is open circuit voltage V0. Remove the load resistor RL, and measure the open circuit voltage V0 at the terminals A and B. The other is the internal resistance R0. Short circuit all the voltage sources from V1 to Vn, and measure the resistance between the terminals A and B. This resistance is called the internal resistance. R0 denotes this resistance. This is the original circuit. If the load resistor RL is connected to the terminals A and B, the voltage across the terminals becomes VAB, and the current IL flows into the resistor RL. This is the equivalent circuit. It has a voltage source with a value equal to the open circuit voltage V0, and an internal resistance R0. Thevenin's theorem states that VAB and IL in the equivalent circuit are equal to those in the original circuit respectively. We can easily calculate the current IL and the voltage VAB in the equivalent circuit. Experiment 3.5. Construct this circuit. Set V1 to 4 volts, and V2 to 2 volts. Measure V1, V2, and VAB. Remove the load resistor RL. Measure V0 between the node A and B. Short circuit the voltage sources. Measure resistance R0 between the node A and B. Confirm that VAB in the equivalent circuit is equal to VAB in the original circuit. The results of experiment 3.5. Pause the video, and check the results. This is the original circuit. VAB was 2.44 volts. This is the equivalent circuit. V0 was 3.25 volts, and R0 was 6.67 kilo ohms. Based on these measured values, VAB was calculated to be 2.44 volts. This obtained value coincided with VAB in the original circuit. Exercise 3.5. This is your homework. This is a resistor network with 5 resistors. Show that if R2 R3 equals R2 R4, then IL equals 0. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.